Hi, in this video I thought we'd have a look at this ultrasonic cleaner. So some of you will have noticed that it was sitting behind me, which is where a lot of my mailbag type items have been sitting. I've had this for about 4 weeks and only recently got round to taking a look at it properly. So I actually had to do some work at home, which meant that I needed to use this to clean up some boards. But what it is a general purpose 3-litre ultrasonic cleaner, and you can use it to clean all kinds of items, so jewellery, car parts, that kind of thing. But for my particular use, it's going to be for cleaning PCBs, and in particular getting flux residues from the underside of components that have been soldered and reflowed using flux. So what we're going to do in this video is have a little look at this device first of all, just to see what it looks like and some of the parts inside. But then I've also extended my flux comparison test to have a look at what happens if you leave flux on your PCB. And that is with flux that has been reflowed, so heated up, and flux that has just come straight out the tube or out the tub. So what we're going to do is clean these up in the ultrasonic cleaner and then see whether these have damaged the surface of the PCB or anything like that, because there's a lot of scaremongering going on saying that you should never leave flux residues on the board, and I want to see for myself whether that is actually the case. Right, so we'll just take a quick look at the listing on Banggood. So this is currently retailing for about £115 delivered, and it's available in 220 volt or 110 volt versions. And what it is a 3-litre ultrasonic bath with the ultrasonic elements running at around 40 kilohertz. And then it's got a timer and heating function. So if we take a look at the front of the device, you can see we've got 2 knobs. The one on the left is for the heater, and you can set the temperature anywhere between 20 and 80 degrees C. And then on the right hand side, we've got a timer for the ultrasonic part. So you can preheat the bath, so you set it up somewhere between 40 and 60 degrees, generally speaking, for PCB cleaning. And once it's up to temperature, then you use the ultrasonic element, and then you just turn the knob to, say, 4 or 5 minutes. And after that amount of time, the ultrasonic cleaner will turn off. And this is actually a mechanical timer, so you can hear it ticking away possibly. So really straightforward in operation. Just twist the knob to wherever you want it, and it will turn off after the prescribed time. I don't think there's much else on here really. It says the power consumption is about 100 watts, and we can have a look at that when we turn it on. It's pretty noisy with the ultrasonic element. Some people say they can't hear the ultrasonic part, but whether or not you can hear the ultrasonic elements, you can definitely hear all of the harmonics and all of the resonances, and it's just a horrible sound. So when we test that, I'll have hearing protection on. But overall, the device seems to be built quite nicely. I'm quite happy with how it looks. And if we take a look inside, you can see what we've got is a basket, and that's what you can put your parts in. And it's recommended that really you put the minimum amount in, because you get the maximum cleaning function. You're not vibrating everything if you've got a 10 boards in there or something like that. But this allows you to lift out your boards or other parts that you're going to clean. And then in here we've just got a stainless steel tank. Now this one doesn't have a drain off function, so you do have to pour it out of here when you're finished using it. It's probably not recommended to leave the chemicals in here for long periods of time, just in case they are somewhat corrosive. But there are larger versions available that have the drain off at the bottom, but I've not found this too inconvenient. And the overall size is not too bad actually. So the actual tank size is, I think it's 140 millimeters wide by about 100 millimeters. So reasonable size PCB. It won't get your biggest boards in there, but 140 millimeters is relatively generous for something at this price point. So there's quite a few different types of solution that you can use in the bath. You can just use plain water, or you can use a bit of dish detergent in there. But for PCB cleaning, it's generally recommended that you use a dedicated ultrasonic cleaning solution. So what we've got here is a couple of different types of things that we could try using. This is Ambersil ultrasonic cleaning fluid, and this was from CPC in the UK. And this was fairly reasonably priced as far as ultrasonic cleaning fluids go. I think it was about £4 or £5 for 1 litre. I bought a couple of bottles of this to try this out. Then we've got this Thermopasti branded water-based PCB cleaner. And this isn't specifically a ultrasonic bath solution, but it is designed to clean up flux residues from PCB assembly. So this should be fine to use in here. And then another one that was recommended by quite a few people is just a plain IPA solution. So not 99.9%, but watered down with some water, or mixed in with a water-based cleaner that isn't going to react with it. The thermoplasty fluid was actually incredibly cheap. I did a video with a mailbag item where I bought this, and I think this 1 litre container was something like £1.20 or £1.30, so incredibly cheap for what it is if it works well. And the IPA is actually also really cheap, so I think I bought 5 litres, so 5 bottles of this for about £12 from Amazon, so also not bad value for money. But what we're going to use in it today is the thermoplasty one, because I've not tried this one out. I used this one for the PCBs that I had to use in this ultrasonic cleaner before, and it wasn't brilliant actually. It does just smell like fairy liquid mixed with water. I think it's just a detergent. So we'll give this one a try today. And what I'm going to do is basically, I think I'm just going to scrape off the excess flux so that we're not wasting the fluid completely, because this is just going to dissolve into the fluid. So I'll scrape it off, and then when we're left with sort of the residue that's behind, we'll stick them in the bath and leave it for a few minutes and see how well it cleans. So just quickly before we clean up the boards, I thought we'd have a little look at what had happened to the actual flux, and if we could see anything happening on the PCB itself. Generally, most of them have remained colourless, but there's one here. This is the best flux. That started to go a little bit green. And then the Amtech 559 has started to go a little bit blue here, but most of them have remained the original colour. But that's on the immersion gold finish. If we take a look at this other board which I prepared, this is onto plain copper clad material, and this one seems to have had a little bit more reaction with some of the flux pastes. So if we have a little look here, we can see again the best has gone extremely deep green. It'll be interesting to see whether it's eaten through any of the copper. The Amtech also seems to have reacted quite violently with the copper here, and also the SIF no clean has started to go green here. But the rest of them actually haven't had too much reaction. There's a little bit of green around here with the Kester rosin flux, a little bit here on the Weller paste, which quite a lot of people said was plumbing paste. So it'll be interesting to see if that's eaten through. And there's also been a little bit of reaction with the thermoplasty halide-free flux here, but the rest of them don't seem to have done much. What I'm probably expecting is that none of these have eaten through the copper, but there'll probably be some quite bright patches underneath where each of these have been sitting. So what we've got here is the same PCB, but this one had been heated up to reflow temperature. So I applied the flux in exactly the same manner, heated this one up to about 230 degrees C, and left it there for a while and then let it cool down. And this one has also been left for roughly 2 or 3 months now. And you can see that there's been quite a difference in what has happened. So these all melted when they heated up and spread a little bit more over the pad. But those that reacted previously, with some colour, don't seem to have had the same reaction here. And then we've got a couple here. So these are the Pros Kit and the Weller Flux. And these have left quite a crusty green residue. Now, I can't remember which of these are no clean fluxes, but what it means is that some of these are designed to be heated up to reflow temperature, and then the residue can be left on the PCB because once it reaches the high temperature, the flux itself is no longer active and doesn't eat through any metallic parts. So we'll put these in the tank face down. And I'll put my ear defenders on because I really can't stand the noise from this. And we'll put this on for about 5 minutes. So you can see some of the cavitation occurring on the boards. I'll put the lid on so we don't get any splashes, and we'll get back to you when it turns off. Right, so that process is now finished, and it's worth noting that the ultrasonic elements of the ultrasonic bath were drawing about an additional 105 watts. So overall, it draws somewhere in the region of 220 watts while it's heating and doing the ultrasonic process. Right, so here we have the cleaned up PCBs, and actually the ultrasonic cleaner along with that fluid has done a really, really good job. So if you recall from the actual video where I did the solder flux testing, some of the highly rosinous flux, such as the Kester No Clean, was actually quite crystalline in large quantities once it had dried out or been reflowed, and it did a really good job of cleaning that up. You can see a little bit of residue here, but other than that, it's cleaned up the board really well. So I've put the link down below for the ultrasonic cleaner if you want to take a look at that on Banggood. But let's take a look at what the flux has done to the PCBs. So the first thing to notice is that the Pros kit and the Weller flux has started to eat through the gold plating on these PCBs. So it looks like the etching is far worse on the one that was reflowed. You can see actually some pitting here, and it started to really eat through the gold coating. Another one that stands out as particularly aggressive is this one, which is number 6, and that is the AG Thermopasty LP1 liquid flux. So although that evaporated really quickly, it was clearly very active because it had left some etching on the PCB that's quite prominent. So that's with the gold plating, which will have a different reaction to the copper. So let's take a look at the copper clad board next. And what we can see here is a little bit more of a story. So first of all, the Banggood yellow flux, absolutely no eating through the copper whatsoever from what I can see here. We've got the best BST223, and that's eaten quite badly through. It started turning pink, which is a good indication that it's eaten through the copper. If anyone's ever etched their own PCBs, you'll be familiar with this kind of colour appearing. So that's done probably the second most amount of etching on the board. This is the Amtech flux, and that's had a serious reaction. So that's probably the most reactive out of the lot. That's actually started to eat through. You can almost see the fiberglass at this point just here. So that's definitely eaten through the copper the most. And then finally, we've got the Kester No Clean with a high amount of rosin in there, and that has started to eat through as well. Not quite as badly as these two, but definitely starting to eat through there. So I thought before we end this video, we'd have a little look inside the ultrasonic cleaner. A lot of people like to see what's inside these Chinese items before they commit any money to it. So let's have a look what it's got. And what we've basically got here is the ultrasonic driver PCB. And the build quality on this is actually very nice. So not really any complaints. I think the only complaint that I've got is the glass fuse, which is a favourite for a lot of the Chinese manufacturers. All that needs doing is replacing this with a proper HRC fuse, but everything else looks completely in order. And there's not a great deal to it, because what we're creating is an LC tank circuit to try and cause the ultrasonic elements to oscillate at their resonant frequency. So they operate as a capacitive element. We've got our inductor here with the transformers which are driving those elements, and there's just a couple of switching transistors here basically, so not a great deal to it at all, but the build quality of this board is fine, so I've got absolutely no complaints with how that is. If we take a look further inside the device, we've got the two ultrasonic elements here which are bonded directly to the stainless steel tank. Then we've got a heating element here along with a temperature sensor and a self-contained thermostat module. So no electronics to go along with this. This is just basically a standard hysteresis control heating element, which is no problem really. No problems with having that kind of heating control for something like this. Then we've got a mechanical timer module, and that literally just switches the AC into the PCB. So a really simple design, not a great deal to go wrong, and actually it's all very serviceable. I think the only problem that you would potentially have is if one of these transformers gave up, then you probably wouldn't find a replacement. But I have seen replacement PCBs available, not specifically for the GT Sonic machine, but there are ultrasonic driver PCBs freely available. You can definitely get them on AliExpress, eBay. I'm not sure if I've seen them on Banggood, but they are available. So you could service this if you needed to. The only criticism really is that this is a resonant driver. So this is designed to drive the ultrasonic elements at their resonant frequency. The more fancy devices will sweep a frequency range so that you don't generate specific standing waves within the fluid that's in there, meaning that some areas of the PCB might not get as much effective cleaning as the rest. So if you spend a bit more money on a more expensive ultrasonic cleaner, you'll get a device that sweeps the frequency range to try and move the standing waves within the fluid just to create a better cleaning effect. But as you saw on this PCB, which was obviously had no components on, it cleaned the board absolutely perfectly. On some PCBs that I had made recently that I had to do for work, we had really good cleaning results. You'll have to take my word for that, but I had no complaints over this. It seemed to clean up the boards absolutely perfectly and gave a really nice finish. And then just on the back panel, we've got the device label, an IEC connector, and this connector also has a fuse in it. So this fuse protects the entire device. The fuse that was on the PCB is just for the ultrasonic part of the device. And the label here suggests that this is suitable for 220 to 240 volts, 100 watts for the ultrasonic and 100 watts for the heating elements. I registered just a little bit more than that with an incoming supply voltage of 240 volts, but it's basically correct. And the GT Sonic brand is quite widespread, so it's available from a lot of distributors as well as AliExpress and Banggood and all the other usual suspects. So I've got no reason to believe that some of these marks aren't genuine. Everything seems to be built properly. It's properly earthed, fused, and everything looks to be reasonable build quality. So I would suspect that this is a reasonably safe device to use in your lab environment. So what does this mean for your ultrasonic cleaning at home? Well, first of all, for one-off or occasional PCBs, you really don't need to invest in an ultrasonic cleaner. You can use isopropyl alcohol, or even better, something like this Electrolube Flux Clean will do a better job because it's got surfactants and other chemicals in it which will help lift and dissolve the flux into suspension so that you can remove it from your board. The downside to this is one of these canisters costs usually around £10, maybe a little bit more depending on who you buy it from, but you can get through this pretty quickly, especially if you are using a lot of flux. And generally speaking, most people on the internet, myself included, use way too much flux for the soldering job in hand. It just makes the surface mount soldering process a lot easier. You don't need to use anywhere near that amount of flux, but if you do use that amount of flux, you get through this really quickly, and that's where something like one of these ultrasonic baths is really excellent, because some of the fluids are very cheap. So you saw today the thermoplasty fluid is £1.50 per litre. There is also some fluid from Farnell, which I'm going to try soon, which is a concentrate, so you dilute it 1 to 10. It's £30 for 5 litres, but it makes 50 litres, so that's pretty cost efficient. What we've also seen is quite a lot of these fluxes are quite active even after they've been reflowed, so cleaning is really important. And if you've got components that are surface mount and there's the possibility that the flux has gone underneath, you may not clean it very well with one of these types of fluids. So you can see here, these ones, if you got that underneath the component, you'd have a tough time getting the residues off by hand, and then you've got the risk that you're going to eat through some of your tracers or something like that under the IC. So in that instance, also an ultrasonic cleaner will be a really good idea to make sure that you've got all of the residues out from underneath components. So I think this GT Sonic cleaner is a pretty good buy. It costs around double the price to get one of the machines that offers the sweeping frequency, which will just give that little extra edge in terms of its cleaning ability. Obviously, if you've got the money or if you're doing this for a commercial venture, you'll probably want to spend that extra money. For home use, one of these GT Sonic machines is absolutely fine. If you are interested in taking a look, click on the links down below. And also, I'll put the listing for all of these fluxes just to refresh your memory, as well as a link to the original video, so you can take a look if you didn't already watch it. So hopefully you found this video useful, and until next time, thanks for watching.